morning, everyone, and welcome to Economic Alliance Snohomish County's Coffee Chats. Thank you for joining us and for taking time out of your morning to be part of today's conversation. I'm Rachel Marrera, Director of Community Engagement at EASC, and I'll be your moderator this morning. Today's session, Powering the Future, Fusion Energy and Regional Opportunity, focuses on emerging area of innovation that, while still in development, is already beginning to shape conversations around energy systems, advanced manufacturing, and long-term economic competitiveness. Fusion energy is often framed as future solution, but what's equally important is how it's already influencing research activity, supply chains, workforce development, and infrastructure planning in regions that are positioning themselves early. This conversation is designed for employers, educators, and community leaders interested in understanding how innovation ecosystems take shape and what it means for Snohomish County and the broader region. Please join me in welcoming today's speakers. Garrison Marr is Senior Manager of Power Supply and Resource Planning at Snohomish County PUD, where he leads long-term energy strategy and resource planning efforts for the region. Garrison, thank you for being here today. Andy Freeberg is Head of Communications at Zap Energy, a company working to advance commercially viable fusion technology. Thanks, Andy, for being here. Diane Kamionka is Executive Director of the Northwest Innovation Resource Center, where she supports entrepreneurship, innovation, and early-stage company development. Diane, thank you for being here as always. And joining us from Clean Tech Alliance, Rachel Ames, Vice President of Economic Development, where she works to advance Washington's clean technology sector through industry partnerships, policy alignment, and economic development strategy. To get us started, I'd like to ground the conversation in what's happening today and how that connects to longer-term opportunity. So Andy, we're going to kick it off with you. How should this audience think about where fusion energy is today in its development timeline?
Yeah, so thank you for having me, first of all, for and setting this all up. I think I sort of want to start by kind of talking a little bit about the scale of this opportunity, just so everybody has like a sense of it. Um, so hopefully, if people are dialing in, they maybe know a little bit about fusion energy. This is the way stars make energy. It is really the dominant way the universe makes energy. But what's really exciting about fusion is how much energy you can get from it. So the same amount of fuel that you would burn for fossil fuels, with fusion, you get 10 million times as much energy. So one way to think about this is like if you think about burning a matchstick. And so everybody can kind of like get a sense of like, if I burn a matchstick, you get a certain amount of sort of heat and light that comes out of that, the energy that comes out of that. If you were to burn a fusion matchstick, a fusion fuel matchstick, you would get 10 million matchsticks worth of heat and light. So it's so much more energy per sort of unit of fuel that you're using. Um, and so what that means, and then so I guess I would say on top of that, that fuel is not wood, it's actually hydrogen. So it's heavy forms of hydrogen, which is more abundant than wood. So you have a fuel that is essentially sort of limitless. It could provide enough energy for humans for billions of years. Um, and then on top of that, that matchstick doesn't make smoke. It doesn't release carbon. It doesn't have any sort of emissions. It leaves behind a certain amount of low-level activated waste. But you also sort of have on the outside of that equation, you also have really limited emissions and impacts and waste. So the thing here is if we can make these fusion matchsticks work, you have this new way to make energy that this is why people talk about it in sort of very hyperbolic ways of it being sort of perfect energy or the ultimate energy source, things like that, because you have this way to make energy that is super efficient, super cheap fuel, limited output. So the scale of if we can sort of solve this is potentially transformational. So really, really big potential opportunity. But to answer the question about where we are in it, so we've been working on fusion, in scientific labs for decades, really since the 30s, or more seriously in the 50s after World War II. And We have come a long ways. We know a lot more about how fusion science works, how the plasma works. We are really starting to go beyond the experiments where we're trying to figure out how to get more energy out of the reactions in our devices on Earth than we put into it. And so we're starting to look way more at how would you actually build a power plant out of a fusion reaction. And so we're kind of in this translational phase where we're going kind of out of the labs and into more of an engineering situation. We're starting to really think about, okay, which of these ways of doing fusion is most likely to be sort of engineering possible and then commercially feasible. Um, and so you're seeing this sort of big boom in resources going into fusion, companies like Zap and our neighbors Helion who have gotten a lot of private investment to try to build these technologies out. We still have things to solve on the science side, but we are helped by how much more computing resources there are now, AI, various things that make that process go faster, and most importantly, sort of decades of understanding of plasma physics and the models that govern it. Um, so yeah, so it's an exciting time. Zap and Helion are two of the only companies that are actually make fusion plasmas every day, all the time. We have operating devices that make fusion. They make energy, but they make it at a loss. So we can't sell it to the grid yet. But we are increasing our performance, and that's a lot of where our effort is right now. As we then also think about, okay, so now once we have gain from the plasma, how can we build the power plant around that? So we're at various stages of that, and it's very exciting to work on. Yeah, I'll leave it there.
That's great. Thank you. So, Garrison, from a utility perspective, how do you approach planning for technologies like fusion that may still be years out but could influence long-term resource strategy?
Yeah, thanks, Rachel. And maybe before I jump into it, just share a little bit about what that process looks like, since I know everybody's not flocking to our website and reading our long-term power plans, every Tuesday. So for us at Snohomish PUD, we're a large utility. We serve about 1 million people. And so we're large enough that we are required by state law to have a long-term resource plan that is updated every 2 years. And so we look out quite a ways. We've actually been planning for the year 2045 for like the last 4 years now. So it's pretty common practice for us to look far out there and think about what our customers' needs are, what our options might be, and what are the ways that we can achieve kind of the lowest cost for our customers with the most reliability with the cleanest energy sources. So those are our goals. Um, you know, Typically, we are looking, especially in the near term, of what are those resources that are commercially available to us to sign an agreement on right now that we can, buy off the shelf, that sort of thing. As we look further on that timetable, we want to be aware of our local fusion partners and the great potential that is. We're huge cheerleaders for our friends' success. And so, I am proud to say that in the late 2040s, our plans consider fusion as a potentially available resource. It doesn't say that it'll definitely be available, and we'll look to our friends to help us adjust the timeline, as appropriate. But we want to recognize that it could happen. And if it could happen, our models assess how good of a fit that would be for our portfolio. And they do find them to be a great, great fit for our portfolio. So our long-term plan does say in the future, fusion could be one of the clean energy resources way out there at the end of the timeline. But we're open to continue dialogue with our local friends here and finding the best fit. But the price point, as Andy was saying, could be really attractive. The resource profile is really in alignment with what our load needs are and what the grid needs. So it's a really exciting technology. So I hope that didn't overdo the explanation of how we're thinking about it. But what I would want folks to take away from that is, we're always planning for the future. We're always updating our plans, and we see, potential opportunities for fusion, and we're really rooting for its success.
It's great to hear. Thank you. Diane, moving over to you. From an innovation and entrepreneurship standpoint, what does early stage industry development typically look like for something like fusion?
Well, good morning, everyone. Um, I will say for an industry with the complexity and the capital requirements that Fusion has, oftentimes the beginning of that industry will start with university research, government finance, just because of the high risk and high volume of all of that. As the product starts to firm up and people can see a visible path to commercial success, then the private capital jumps in, the private businesses jump in because the risk is lessened a bit from the high risk of the early stage startup. And then eventually the wider population of investment and industry can start to jump in. If we kind of think back, I believe most of our memories can go back to the start of the solar industry. For example, when the solar was first started, it was a lot of manual manufacturing, high cost, slow production, low volume, uh, difficulty with, or challenges, I would say, at some times for getting the excess energy onto the grid. That required some adjustments and procedures. As Garrison said, they look way out, but it's a big, heavily regulated grid, and to make a change to it is a big deal. So it takes quite a bit of time. But now we don't think twice about fusion as being, or solar rather, as being part of our just the typical energy environment, and it's been integrated in it, and that hasn't taken all that long. So once Andy and others get the formula to the point where it's a power positive, I think we'll see the fusion industry move very quickly. So it'll be interesting and fun to watch.
It's exciting to watch. Thank you. Rochelle, moving over to you. How does fusion fit into the broader clean tech landscape here in Washington? And what are you seeing at the state level?
Awesome. Hi, everyone. Great question. I think it's been really interesting to watch the transformation of how the fusion industry has been perceived statewide over the past probably 5 to 8 years since I started at the Clean Tech Alliance. One of the things that used to happen a lot is that we would bring up fusion energy in conversations, and a lot of folks kind of defaulted to thinking of fission energy. So I think one of the biggest things that I've seen in terms of the most recent times in transformation is that people really do understand that there is a difference between fission and fusion energy, and also that there is a lot of people excited about this type of technology that maybe hadn't been thinking about it before. I know my brother-in-law will ask me questions around like, "Hey, when is fusion coming on the grid?" And he's not in the fusion industry. He is in a completely different industry. He's in Boise, so it's very interesting to hear a lot more kind of folks across both the utilities spectrum thinking about how fusion can impact their long-term planning and the grid resources, but then also local businesses trying to understand, and that's an interesting connection into how our larger industries are thinking about powering themselves. Microsoft, for example, with their power purchase agreements with Helion, folks that are looking for new ways and new technologies to partner with as well.
Great. Andy, moving back to you, what are some of the key milestones or indicators that signal progress in fusion development, especially for a non-technical audience?
Yeah, so it is a technical thing in certain ways, but the one thing you'll hear a lot about if you start reading about fusion is this idea of Q, and Q is the ratio of energy into the plasma and energy out of the plasma. Um, and so if you're at Q equals 1, that means the same amount of energy you put in, you got out. And so what you really want to do in fusion is you want to get to a Q of 10 or something. So you put 1 unit of energy in, you get 10 units out. 1 megawatt in, 10 megawatts out. Um, that is a really important one. It's important sort of no matter what you're doing, what kind of the way you set up your plasma and that kind of thing. And then from there, the next thing you worry about. So there's one place on Earth called NIF, the National Ignition Facility, where they've made a Q greater than 1 plasma. They've made a sort of Q of 4 or 8 plasma. But Now you start going, okay, well, that doesn't include everything that you use to sort of generate the plasma, to make all that heat, to build that little star in a jar. Um, and that's sometimes called the engineering gain. So, sort of, can you build a power plant that actually makes more power than the power that it's consuming, right? And as you can imagine, if you build a really convoluted way to make a plasma that gives you a high scientific Q, that doesn't really help you if you can't build a power plant around it. So people are starting to look at that sort of engineering Q as one of the big, or engineering gain as one of the big things we also need to think a lot about. And then the last thing is the commercial gain. So then, will people be able to really show? And it's going to be, as Diane said, like there's a risk equation in all of this, right? And what are the odds that based on the sets of things you have to do, you have to build a cryo plant, you have to bring in a bunch of liquid nitrogen, like what do you have to do? And how does your whole kind of plant balance of plant cost thing go? So at ZAP, so I guess for a little context for ZAP, we spent out of the University of Washington doing a very specific thing called the shear flow stabilized Z-pinch that two professors at University of Washington were working on since the 90s. Spun out in 2017 to kind of commercialize that after success in some DOE programs. Um, and so they've been doing this specific kind of fusion for a very long time. We just a couple weeks ago announced that we are actually going to build fission microreactors, which again are different than fusion microreactors, but are the nuclear power that we know about and that we know works. And both fission and fusion make their energy in the form of neutrons. So these neutrons, if you remember your science class, there's protons, neutrons, electrons. Neutrons come off. They're carrying all this energy. You have to hit something and heat it up, and then that's how you make electricity. So for us, if we build a reactor that's sort of a similar scale to our fusion device, we try not to use the word reactor with fusion because of NRC stuff, but we build a fission reactor that's sort of small scale. It makes neutrons through regular fission processes. It can teach us how to build our power plant, and it de-risks the whole idea of the fusion plant later. So once we have gain, we can say, well, we've already built these fission ones that are not so different in lots of ways. And then that helps investors have more confidence in our ability to go towards a plant. So all that stuff matters. I also put in a plug for the U.S. milestone-based fusion development program, which is the country's national program that's based on milestones. So taxpayers only pay if the companies hit these predetermined milestones. So the money isn't sort of promised and you can't default on it or anything like that. It's a really good program. ZAP is one of 8 companies in that program. And it's because it's hard for us to know what the right milestones are, as sort of, I'm not a scientist myself, I'm a communications person, but the physicists say, well, these are the milestones that they need to hit to show that they're on the right path. So that's a really good program. That program I hope will grow because I think it's a really good way to encourage fusions development.
Thank you. We just had a question come in the chat from Donna. Donna is asking, would AI data centers be early adopters of this technology?
100% yes. I mean, there's no question that hyperscalers have more willingness to pay and take a certain amount of risk than ratepayers. I mean, so Snowput is not gonna like put a bunch of money into an unproven technology. They're very conservative. They're very careful. Now, Microsoft, Meta, Amazon, like they can take some of these risks, and they need to because, as I think people know, like their rates are going to go up because of data centers, and so they know that they have some risk in public sentiment. And so yeah, all the fusion companies are talking to them, fission companies as well, knowing that they have big needs.
Thank you. Garrison, how do emerging energy technologies begin to factor into infrastructure planning and grid readiness over time?
Yeah, thanks. I think we're seeing a lot of responses in the market to some of the big resource types that are getting built today and what could be a good complement to those resources. So some of the emerging technologies are honestly a great fit for what the grid needs. And maybe to make that less abstract, I would say that, right now there's a lot of solar, a lot of wind being built, which is, terrific in many ways because there's no fuel costs associated with what's needed to generate electricity there. But, you know, the sun is not always shining and the wind is not always blowing. That might be more true where I'm standing in Everett than in other parts of the world. And so those emerging technologies that are either always on, which we call a baseload generation technology, or those technologies that can ramp up and down, on or off, uh, at the grid operator or the utility or the market operator's discretion, those can be really great complements to the other resources that are already on the grid. And so we're seeing those sorts of things. Fusion's a great example of that. Breakthroughs in battery technologies, those are helpful. Enhanced geothermal, we're seeing some promise there as well. So some of these technologies are sort of looking at the grid and saying, what does it need? How can I help? And that's terrific. The other thing that I would add is that those technologies that can be safely sited closer to where electricity is consumed, that's a big advantage for the regional grid and for consumers. And the reason for that is generation resources do take a while to build and construct, uh, but transmission resources take longer typically. So long distance transmission, especially from the east part of the state to the west part of the state, that can take a while to build. So those resources that are good, clean, safe, and affordable here for the west side, that could really reduce transmission risk, transmission cost, and transmission timelines. And those are all things that we love. So that's why we're rooting hard for these emerging technologies for sure.
For sure. Diane, what kinds of support systems, funding, mentorship, partnerships are most critical in helping early stage technologies move forward?
All of those items that you mentioned, Rachel, are critical, and it's hard to really say one is more important than the other because when you're in the early stage of a technology, it's kind of a balance. So it's a little bit of a Rubik's Cube to get everything on the right side and in the right order. I would say that mentoring in the very early stages is perhaps a little bit more important, getting advice on how to get off the ground. Most innovators have a subject matter expertise, but not often a broad business understanding or expertise, and mentors can kind of add to bolstering that expertise and giving guidance. Then businesses and partnerships and funding come into play again with additional ideas. I will suggest that, as is happening now in the fusion industry, businesses are a great source of funding. They not only provide capital, but they provide partnerships and credibility and relationships and a customer. So they add a lot more value than money. We've actually had some entrepreneurs that we've taken into people and venture capitals, and the venture would say, we can write you out a check, but that's not what you really need. And of course, the entrepreneurs do not like to hear that, but it's really true. They need more broad resources. And I would say that as the fusion industry is developing those broader partnerships and relationships to help influence policy changes, to help influence workforce development, et cetera, become even more critical so that the innovative startup doesn't have to bear the weight of all of that work themselves. They can depend on the credibility of their business partner, et cetera. So I think that is something that should not be overlooked in the long run for something as big as the fusion opportunity is.
Right. Rochelle, what role do organizations like yours play in connecting industry, research, and policy to support these emerging sectors?
Great question. And Diane set it up perfecly right into my answer. It really is that that wide base of resources that you find within organizations like ours. We're a 501c6 trade association. We have industry members, we have research partners that are members, we have government agencies that are members of ours. We also have those folks that are working on policy, that are attorneys, that are service providers for those emerging companies. And part of the reason why we need everyone working together and at least aware of these challenges is that clean tech broadly is very challenging to commercialize. There's not set milestones, although the program that Andy mentioned is really helpful because that does allow, at least within the fusion industry, folks to see like, okay, if a company hits this milestone, that means that they're on the right track. With a lot of clean tech, and especially in those emerging technology areas, you don't know what the right track is yet. There's a lot of pivots, there's a lot of places where you do need that partnership and that input from potential customers down the line. And that's really what our organization kind of brings to the forefront, is that wide breadth of folks that can give you feedback on, hey, would this actually fit on our electric grid and fit what Garrison needs? Or is this really not the right kind of implementation and commercialization pathway you should go for? It actually should be more on helping a industrial emitter, like with their decarbonization plan. So there's a lot of different pathways like that, and that's really where we thrive, is bringing everyone together to say, hey, let's analyze and figure out and give you feedback on what the technology should be doing. I'll also put a plug in for our innovation clusters that actually bring competitors together to really identify those industry challenges that they can work on together. So it may not be on the technology specific, but it is on that broader ecosystem, like Diane mentioned, around workforce, around policy, around community engagement, and learning from each other, because we do need to move faster, and clean tech is pretty slow in terms of commercialization. So that's really where we try to help move things along.
Thank you. So Andy, moving back to you, as fusion companies grow, what kinds of supply chain or partnership opportunities are starting to take shape?
Yeah, I mean, I think Diane kind of talked about the early solar industry, and we're in a similar situation, which is, we're prototyping a lot. We're doing a lot of custom kinds of things along the way, and so as has been discussed, speed is everyone's kind of like, when is this going to be ready? We really need this, and so we're still pretty early in the ultimate growth, which means like we look for, partners who can do stuff quickly, who can do custom orders. What supply chains really like is like big orders that are known for years into the future, and we just can't really offer that in a lot of ways right now. So we will look for people who, want to work on fusion, that want to work on something that will have an impact, maybe even a historical level of impact, and sort of are excited about that sort of mission side of it as well. And we've been lucky that way. I mean, this region is known for innovation, the aerospace industry, the biotech industry. We have a lot of really great places we can go, even locally, to work on stuff and to build stuff with. So yeah, so those are the kinds of things we're looking for. We're like, we get great just even inbound people, like, because we're a startup, 150 people. We're not always putting out big RFPs or anything like that. So like even people who are coming to us and saying like, I've got a machine shop and I'd love to, do work for you. That kind of stuff is great. And so, go to our website or send us an email at reachout@zap.energy. We're happy to have people kind of come to us and say, this is something I really care about and believe in, and would love to sort of work with you. So yeah.
That's great.
And
Thank you.
we expect that to grow. Obviously, hopefully, currently there's a couple hundred employees, still sort of less than 1,000 between Zap and Helion and some of the other companies. So, could be a lot bigger than that.
We look forward to that. WSU, I'm sorry, this is a question from the chat from Oak Rankin. WSU received a federal grant support to train future workers in nuclear energy. Are you partnering with them? And if so, what does that look like for Snohomish County? If not, who are the partners you have or are looking for, and what could that mean for the county? I'm guessing that's
Stuff
for
for
you,
me?
Andy. Yeah.
Yeah, I mean, so we actually look to WSU and Clean Tech Alliance and some of the groups to like help set those networks up. We take a handful of interns, like we actually really prefer to get people who have spent a couple of years working at a national lab, working at a university lab, that kind of thing, so that they really know their way around. Because as you can imagine, you get sort of super early career employees, and they need a lot of training and investment themselves. So we don't have a formal a relationship with WSU, but we again serve in this thing called the Fusion focused on Fusion cluster with the Clean Tech Alliance, which includes WSU. We talk about workforce stuff all the time. So informal, and maybe that becomes more formal, especially the sort of fission part of what we're doing is new. And so we are definitely looking at different partnerships that make more sense for the fission side, where we're closer to commercial. We can build it now.
Great. Garrison, how important is coordination between utilities, industry, and policymakers when preparing for future energy systems?
Well, it's certainly helpful, that's for sure. At the PUD, our mission really is just providing affordable, reliable, and environmentally responsible electricity. So when we show up in the policy space, those are our goals, right? How can we advance our customers' interest? And uh, you know, thinking about maybe an example where we brought those things together in a positive way. We were pretty active 2 legislative sessions ago at the state level on Senate Bill 5445. That Senate bill was legislation that provided regulatory compliance credit for things like demand response investments, some battery investments, generation within county on existing property, those sorts of things. It was an opportunity for us to reduce some of the regulatory costs associated with the clean energy framework, but also make local investments, that could result in lower costs for our customers. Lots of wins stacking up there, all in a positive way. Those are the sorts of things that get us, pretty fired up. Is where we can find those opportunities to, accelerate investments, to reduce costs for customers, and advance our clean energy goals so that we can move through the future in a positive way.
Thank you. Diane, Andy mentioned workforce a little bit earlier. Thinking about workforce, how do regions begin preparing talent pipelines for industries that are developing, such as fusion?
So I would emphasize primarily looking beyond short term, that the innovation companies themselves, such as Zap and Helion, are heads down focused on getting their product working and running and ready for commercialization. So that leaves room for the rest of us to think about, okay, what comes next? What other kinds of positions are needed, and what can we do to prepare them? Because oftentimes the skills training comes a couple of years before the market is ready for them. So what kind of skills can you develop that people can get jobs for now, and increase their understanding and knowledge and values, so that as the supply chain and the support and all of those things that Garrison mentioned, the PUDs will need to upgrade the grid, the increased cybersecurity requirements, et cetera, that are going to be there. We should be working on those things now. I would also put a plug in to not forget entrepreneurs and innovators, because in addition to workforce, there are very valuable aspects or resources for what comes next, and they can help provide startup education and workforce opportunities for people who become valuable as the industry matures as well. And then there's the pretty obvious thing of, this is a long-term growth industry. So getting people in high school and middle schools understanding and excited about the industry, so that they are more interested in getting the kind of training that they need, is really starting to set the long-term pipeline for that.
Thank you. And shout out to Zap. I know you actively participate with our Snohomish STEM program, visiting middle and high schools and sharing information and workforce opportunities with them. So
Shout out to the program. That's a good
Yes,
program.
definitely. I know Alyssa Jackson is on the call now. Rochelle, moving over to you, what are you seeing in terms of workforce trends or gaps across the clean tech sector that might also apply to Fusion?
No, and I think this is seen across the clean tech sector. So this is a great question. Is that we're seeing the same things across no matter what type of clean technology, sustainability, even just building technology generally. We need engineers now, but there's also a need for technicians and apprenticeship programs. And one of the challenges, though, that we're seeing with that secondary need on the technicians is that to add more apprenticeship seats, we need projects, we need jobs, and so we need to speed up the permitting pipelines. Garrison talked about transmission needs and those challenges. Is that's also challenging for those projects that are trying to bring power to the grid. So even like right now, we're seeing kind of this like chicken egg problem of we have a lot of projects in our transmission pipeline that want to get connected to the grid, but they don't have a clear timeline on how long that's going to be, so they can't start their building process. So it's kind of in the same vein too of how fusion energy is we're trying to make sure that everything else is kind of ready on the workforce pipeline so that when we are able to scale up, we'll have workforce that's ready as well. One thing that I will mention too that we're doing both with the companies and our focus on fusion cluster and broadly at the Clean Tech Alliance is that building more awareness of opportunities both in the fusion sector but also other clean technology jobs and connecting that with other sectors in K through 12 as well as at universities. So that question on Washington State University's program, we're really excited that they were able to get that federal funding because that's going to be broadly a lot more people aware of those opportunities within the nuclear space, fission and fusion, as well as just other clean technology challenges. I think that's the other part is that we want everyone to be aware of, hey, you can be working in clean tech and these are all the different opportunities. You can be an accountant and work in clean tech, but you need to know kind of, hey, Zap's hiring or these folks are hiring or these are viable companies that you should be supporting. I'll also say that, and thank you to Lindsay, my colleague who's on the call for dropping this link to me so I can share it with you all, is we have worked on a virtual power plant, or virtual fusion power plant with our fusion companies so that you can kind of get a better feel of what would that even look like especially for K through 12 students.
Thank you. This is a good opportunity to mention that we will be sharing a post-event email with resources from today's discussion, so we'll be sure to include that link that was just shared in the chat. Moving back to Andy, what opportunities exist today for local businesses or institutions that want to engage with or support fusion-related work? Oh, you're muted, Andy. Sorry.
Muted. Yeah, I mean, so we're actively, doing all kinds of projects. As I mentioned before, I think we're always looking for we're hiring people, we're always buying things, or we're looking for contractors to work on various aspects of the projects. So, send stuff to us if you think that you're aligned with what we're trying to do. Make sure that we know you exist and that you're in our databases and that kind of thing. And do the same with Helion as well. And yeah, we can keep building it all together.
Thank you. And Garrison, how do you balance innovation with reliability when evaluating future-facing energy solutions?
Yeah, I guess I'll be deliberately provocative here. That's not really a choice that we can make. Reliability is our responsibility, and we take it extremely seriously. I think about the medical facilities we serve. The cool R&D taking place that we've heard about today. We don't want to be the reason that any of those critical things fall short. So that's our number one goal. But I would say that there are plenty of emerging technologies and innovations that we think advance reliability and that we're really excited about. One example of that, we're spending quite a bit, and we're really excited about a automated distribution management system that is going to make our distribution system more reliable. It'll give us better control of that system, that's an investment and an innovation that puts us, among the leaders of grid management. But it's something that increases our reliability as well, where we can use control systems instead of sending, crews to some spots in some instances that just make us faster and better. So those are the places that we look, but unfortunately, we just have to make sure that we're that reliable, resource for folks. So can't balance it, just gotta have it.
Thank you. Diane, moving back to you, what distinguishes regions that successfully position themselves early in emerging industries from those that don't?
I would say one of the primary things is a very heavy and high priority collaboration of industry, government, education, funding, investors. It really needs all of those individuals working together to remove obstacles. The region has to set itself up to be rather risk tolerant and excited about things. Reward failure and as well as and forgive failure, both, and then also reward success because that's just part of the innovation and successful environment. Our area is in an interesting transition. The King County area especially was so focused on software engineering for so long, and now the new potential innovations is around fusion and other innovations going forward are very different. That it require a different investment capital, a lot more capital and slower response, maybe lower margins than what our traditional infrastructure is accustomed to. So we've got quite a transition that we all need to make to absorb the reality of the innovation of the future. It's a little bit different than what we've been blessed with over the last few decades. And I think just to put a plug in for the area that we serve, which is Snohomish, Skagit, Whatcom, everything up to the border, that's an area that makes things and they grow things. And so applying the technologies to those industries make that a very rich opportunity for innovation in the future. And I think having the two top fusion companies in that region is pretty amazing. So I think that would be what I would suggest mostly is that we all get together and celebrate success and keep collaboration and innovation very high in our minds and don't be afraid to fail.
Yes, thank you, Diane. Rochelle, moving back to you, what does strong ecosystem alignment look like across sectors, and why does it matter at this stage?
Yeah, I would say we've touched on a few of them. We've touched on workforce, that need where you can have that mobility across different sectors, whether that's even starting in a large company, going to a startup, starting your own startup. That's really important to have those pathways and understand, have those ecosystem connections so that you can have that mobility. We've also talked a little bit about supply chain. We want to make sure that we're building stuff here. Like Diane mentioned, is that continued building. We know that disruption of supply chain really can be make or break, especially early emerging sectors, as well as if you don't have the right supply chain in line, and something goes wrong with one of those pieces, then you're behind one of your competitors. So that's super important. We want to build things here where that doesn't happen, and that all of the companies within the ecosystem can benefit. The last one, and we touched on a little bit, that policy and regulation piece really needs to be aligned across sectors so that we do see that innovation and new development, and we aren't stifling that across potential opportunities. I think that's the key piece that we look at the Clean Tech Alliances. Hey, if we're going to do something, let's make sure that we're looking at all of the different applications for it. Let's not just make a regulation that's going to exclude one piece, or let's make a policy that, that may help carbon sequestration, but also geothermal energy and geologic hydrogen, for example, or in a case like fusion, is there something where fusion and fission, it's alignment, or also pieces where it's like, hey, these two need to be separate for XYZ reasons, those smart kind of policy and regulation pieces. So I think this region is doing a really good job of that statewide, is looking at that. But I think there's still obviously more, always more opportunity to look at how are we aligning these sectors that maybe seem very disparate, so that we can have policy that makes sense for our utilities as they're bringing these new technologies onto the grid.
Thank you. So we're going to open this next question up to all of you. How important is cross-sector collaboration and building a strong foundation for something like a fusion ecosystem?
I guess I can start. We try to strike a really careful balance on collaboration and competition. There are certain things there are certain ways that we certainly want to collaborate. We definitely focus on transparency. We publish peer-reviewed research and participate in the plasma physics community. We participate in the local community in ways that we can. But we also really recognize that collaboration for collaboration's sake is not a thing that's going to speed us up. And so we also feel very competitive with Helion, for example. And you can imagine we have a little bit of rivalry there. And I think that's good. I mean, I think it's a thing that drives us and hopefully drives them too. And so we really try to be, thoughtful and strategic about the ways that we collaborate, who we collaborate with, and why we collaborate with them. And then we also sort of just recognize that we're a company and we want to get this thing to market and we want to be the first ones there. We don't want to give away all the secret sauce. And so we think about that a lot.
And I'll just jump in briefly and piggyback off of Andy's. We like to use the word coopetition or cooperative competition. So that is that hey, we are competing, but we have these pieces where we can align and can work together to really bolster the ecosystem. But also I think that having kind of folks like our organization and Diane's, where we can kind of de-risk that relationship, where it's there is some spaces in between where you're not having to just have the conversations by themselves, although they can. I'm sure that Zap, Helion, and other of our fusion companies in the state are having conversations without us, but it also is a way that we can provide value back to the ecosystem, is providing a forum that is a little bit of de-risks and less technical, and you're not getting into those spaces that are really where the competition is happening.
Love that co-opetition. That's great.
Just a quick comment also that oftentimes we'll be in a room of entrepreneurs, and we are industry agnostic. We help entrepreneurs in a number of different industries, and it's amazing how much they gravitate to each other and share tools that they've learned or tricks that they've learned in one industry that applies to the other, and they're very encouraging with each other. So I think, especially at the earlier stages, that becomes really helpful for what's to come in terms of the innovations that are going to be needed to support the whole fusion industry.
Thank you. So looking ahead, what should employers, educators, and community partners in Snohomish County be paying attention to over the next few years?
Just to kick it off, I would say that the most important thing is not to become complacent, to think we've got it all figured out because of our history of innovation, etc. Or perhaps after the first couple of fusion successes, we sort of figure we've got it all figured out. But this is going to be a changing and ever evolving industry, I believe. I don't think it's going to end just because somebody, one company or another, kind of cracked the nut and made it happen. I think there's going to be continuous improvements, and we ought to be keeping aware of that and staying ahead of the game so that we don't become yesterday's news, so to speak.
Well said.
Yeah, I think we've got a little ways to go on this, and we have to sort of continue to keep the energy, no pun intended, up on and keep pursuing it and recognize that the we're very lucky to be where we are and have this chance that there's only a few places in the world that have more kind of fusion infrastructure and expertise built up at this point, and that's pretty exciting. So but sort of the seed is planted and starting to sprout, but the plant has not grown all the way yet. So we have to tend to nurture it.
Thank you. So in closing, what's one key takeaway that you'd like this audience to leave with today regarding fusion energy and regional opportunity?
I can jump in first just to kick it off. Fusion energy is coming, and I think it's one thing where everyone can participate, especially as these companies grow. Is you don't have to be a plasma physicist to pay attention to what Zap and Helion are doing, and or participate in the supply chain, or be a part of this. And I think that's true for any kind of clean technology sector. And selfishly, we represent all of them, and so we want everyone to be thinking of ways that they can participate in the clean technology ecosystem, whether that is just helping support companies and providing feedback and their resources and expertise and mentoring, like with programs that Diane does. All of our companies that are emerging in these spaces like need support outside of even the technical spaces. So if you're not a plasma physicist, you can still participate in clean technology, and a lot of it is just finding ways to go meet with these companies, understand and talk with your kids about what the opportunities are, and educate yourself on the type of technology, because it's really cool, but also it's going to help make sure that we can keep the lights on and work on what Garrison's doing, and making sure that we can always turn that switch on, and it's going to be reliable, and also hopefully continues to be something that we can expand, as well as that there's lots of opportunities for everyone in it.
Well
Garrison?
said.
Yeah.
I'll hop in. I imagine we've got some PUD customers on the call as well. So this is just a great opportunity to share with our customers. Hey, we're always planning for the future. Shared up front that, we're doing these long-term plans every 2 years. We're looking out quite a ways. When I talk to customers, oftentimes they're like, will you be ready for electric vehicles or more air conditioning load, or what about data centers? We're planning for all of those things to make sure we're in great position, and we are. For our fusion folks, I would say, we are focused on being a world-class supplier right now for you, to make sure that you keep innovating towards when we could potentially be a world-class customer. And we're very open to that. We've been thinking about it, and we're just rooting for Team Snohomish County here, and wanting to see us all, get to a great place.
I will, yeah, I mean, I guess I'll end by saying, like, in a world that there's a lot of things to be concerned about, like fusion is something to be hopeful about. And that's really exciting. It is the science that we're working on, the understanding of fusion is real. So it's not an if, it's really just a matter of when and where. The group is that figures out the right way to do it. And so, yeah, if none of that when is not a given at this point, and we are excited to be, here where we are building it, but it's going to take a lot of passion and dedication to get it all the way there. So we're hopeful that some of the people on this call will be supporters and help us get there.
And I would also think that we should be taking away a feeling of excitement for being and pride, really, for Snohomish County to be such a leader in something as important as the fusion industry going forward. And I think if we all continue to keep that attitude going forward, and keep the energy, so to speak, pun intended, I guess, high, that we will look forward to a really good future of contributing to the energy and the power that we need for going forward.
Thanks, Diane. And Rochelle just shared a plug in the chat for a save the date for the Washington State Fusion Week event in Everett on August 31st, which will be once again at WSU Everett. So we're excited for that, and we will share more information in our post-event email. So thank you all for being here. Garrison, Andy, Diane, and Rochelle, for sharing your time and your insights today. And thank you to everyone who joined us. Today's discussion highlights an important theme. Innovation doesn't just arrive fully formed, it develops over time. And in regions at that early stage, through collaboration, planning, and ecosystem building, we are better positioned to shape and benefit from that growth. Whether it's through infrastructure, workforce, or partnerships, there are meaningful ways for our region to stay connected to emerging opportunities like fusion energy, even at this early stage. At Economic Alliance Snohomish County, we're committed to convening conversations like this that connect innovation to practical regional outcomes and to help ensure Snohomish County remains competitive in a rapidly evolving landscape. We encourage you to stay engaged and continue exploring how your organization can be part of this work. Before we go, we'd like to invite you to our next coffee chat. Sorry, Megan, if you could move to the next slide. We'd like to invite you actually to June 2nd at Boeing Future of Flight for our annual Snohomish County update, featuring a keynote address from the County Executive, Dave Summers. This event will provide a comprehensive look at county priorities, fiscal sustainability, and what's ahead, bringing together regional leaders to better understand the opportunities and challenges shaping Snohomish County's future. And we'd also like to invite you to our next coffee chat. From fans to foot traffic, FIFA's impact on tourism and local business. This conversation will focus on how our region can prepare for increased visitor activity and how employers, small businesses, and tourism partners can position themselves to benefit. And that will be on June 9th. To register for these events or to learn more about EASC and our work, please visit economicalliancesc.org or scan the QR code on your screen. And once again, thanks so much for being here this morning. Let's go to gallery view now so we can see all your smiling faces. And let's raise our mugs to partnerships, civic engagement, and thoughtful policymaking that helps keep Snohomish County's economy strong and moving forward. Take care, and we'll catch you at the next Coffee Chats.